Hello, this is Ananya. Today I will be taking a rough set theory, a mathematical approach to understanding uncertainty in data through boundaries. In our data-driven world, we often encounter situations where information is incomplete, imprecise, or uncertain. In traditional dataset theories, deals with crisp boundaries and either element belongs to a set or it does not. But what if we can't be entirely sure that where a rough set comes into play? And the core concept, why rough? Um, Imagine when you are looking at a cards and you only know the type of its color and fuel type, but if the different car models are there, but by knowing only two attributes, we cannot say that both are same. That is where rough comes into play. And theory approximate a set using two boundaries, which are very important. Lower approximation, upper approximation, and using them, we'll know what is boundary region. In mathematical foundation, this is the representation. S is equals to U comma A. U is universal set of all objects, and A is set of attributes describing the objects. And discriminability relation, this is the way of representation. IND of B, and this is how we'll represent it. And approximations, the heart of subset theory. And I have said, low approximation. It is where it is a positive region. Objects whose equivalence is equal to entirely contained in the X. And upper approximation, at least one element it should be there. Then we can give it as a we can keep it in upper approximation. It is possible region. And boundary region formula is upper approximation minus lower approximation. Uh, it is objects we cannot definitively classify. And I have given an example for it. Here the dataset, patient ID, and attributes are headache, temperature, flu test, and diagnosis. In this example, we will ignore the flu test as we will identify using headache and temperature, which are true attributes. So we'll diagnose the diagnosis. We'll predict the diagnosis. Objective: determine rough approximations of for patients diagnosed with the flu using only symptoms, which is headache and temperature in this dataset, ignoring the flu test. Step one, based on temperature and headache. So we'll classify them using those attributes which have same. Here P1, P2, P6 has same. Headache is yes and temperature is high for everything. So like that, we'll classify. Here P6, P3 and P7 have same type. Headache and is no and temperature is normal. Is it for P7 also? So like that, we'll first of all classify. And here are the uh, uh, data after classifying. Uh, Define the target set. We want to predict the patients with the flu. So that is the target set. So P1, P2, P5, P6 have flu. So that is the data we have. And here lower approximation. Here P1, P2, P6 as we have classified here. This set all have flu. So it will be considered. And here P3, P7, no one has flu. It is not in our target set, so it is not there. In P4, it is healthy. We don't want it. And P5 has flu, so it will consider it. So in low approximation, P1, P2, P5, P6 will be there. And in upper approximation, here also partial it is not there for in this example. So P1, P2, P6, and P5 will be in upper approximation also. If in this example, if P3 have blue, then we will include P3 and P7 also. Like it is upper approximation, so we'll use it. And here, calculating the boundary, we'll get empty set. Upper is equal to lower, so we'll get empty set. Interpretation is with the attributes headache and temperature, we cannot perfectly classify flu patients. There is no uncertainty. If there is uncertainty, we'll get some. data here, not empty set. And here I modified with this example only. Now, let's remove the temperature attribute and only use headache. Now we'll classify them using headache. Headache, this P1, P2, P4, P6 has headache, and P3, P5, P7 is not there. So it's zero. Here, lower approximation is P1, P2, P4, P6. Upper approximation, P3, approximation is everything. This set contains P1, P2, P3, P4, P5, P6. Here, lower approximation is empty set. I'm sorry. And here, boundary region is upper approximation minus lower. So we'll get all the patients. Interpretation is using only header. We cannot definitively classify any patient. Everyone falls into the boundary region. Here is the Venn diagram for the upset approximation. This is universe and this is approximation and this is lower approximation. And here accuracy and quality of approximation. This denotes cardinality. So accuracy formula is a lower approximation cardinality by approximation cardinality. For our first example, it is 4 by 4, it is 1, perfect classification. And our second example was 0 by 7, it is 0, no definitive classification. Here is the main thing, interpretation. If alpha is equal to 1, x is crisp, perfectly definable. And if it is between 0 and 1, x is rough, uncertain. And if alpha is equal to 0, then x is extremely rough, high uncertainty. And for this example, it is uh, graph, like patient classification example. Here, two main things for it, redundant and core. Redundant reduct a minimal subset of attribute that maintains the same classification power as the full set. Here, core, the intersection of all reductance attributes that cannot be removed. In our example, full attributes was headache and temperature. For testing, we have removed the temperature, classification was failed. In testing, remove headache, classification may still work with the temperature alone. Temperature alone might be sufficient, make it a potential reduct. Here is the flow of the rough set algorithm, how it works. First, we'll start it, take the input and generative equivalent classes. We'll define based on the attributes and find the lower approximation, upper approximation, and we'll find the boundary region and calculate the accuracy. That's time. Yeah, few applications of rough set theory are medical diagnosis, identifying the key symptoms. In machine learning, feature selection and rule extraction. And in data mining, pattern discovery and segmentation. In finance analysis, like risk assessment and fraud detection. In image processing, dealing with the fuzzy or noisy dataset. And I have listed the few advantages and disadvantages of rough set theory. And the main advantages are that it handles uncertainty without needing probabilities or prior knowledge, and it helps discover patterns directly from the data. However, it can be sensitive to noise and works best with the discrete data. Here are the some limitations: sensitive to noise data. And in the main advantages are that it handles uncertainty without needing probabilities or prior knowledge. That is the main advantage. And to conclude the rupture theory, it is a simple yet powerful tool to for making sense of uncertainty by defining clear and rough boundaries. It helps us make informed decisions even when the data is incomplete or imprecise. Thank you.